One of the beauties of science is that it's ever-changing. It's never the case that any one rule or theory is totally safe from being tweaked, rewritten, or entirely thrown out. Even with the most fundamental pillars of scientific thought, it is possible to alter how we understand them when and if new evidence comes to light. In a 2022 video, we took a closer look at how one particular study had potentially proved all of physics wrong. So be sure to check that out after this. But for today, it's all eyes on space and the universe, as researchers believe they may have found something that could change everything. When we look to the sky above, we see stars, but no one star is the same as any other. And they're all positioned at different distances away from the Earth. Some are just a few light years away from us, some are a few million. The farthest star ever recorded is Arendelle, clocked by the Hubble telescope in 2022 and calculated to be a staggering 28 billion light-years away from us, about double the distance of any other star ever discovered. It's thought that Arendelle formed somewhere around the end of the first billion years of the universe's life after the Big Bang. But there's some confusion here and possible discrepancy. Arendelle is 28 billion light-years away, but it's only 12 billion or so years old in a universe that's only 13.8 billion years old. How can that be? Broadly, the answer is universal expansion. We know that the universe is expanding out and out, seemingly pushed by an unknowable force, potentially that of dark energy. We also know that the rate of the expansion of the universe is accelerating. Over the 20th and 21st centuries, scientists and astronomers, including the likes of Albert Einstein and Edwin Hubble, have been able to reach that conclusion thanks largely to a natural phenomenon known as redshift. Redshift is the apparent reddening of a distant object as the light that it emits gets effectively stretched out. While it's bluer if it's nearer, if it's redder, then it's further away. Famously, Einstein hadn't originally allowed for an expanding universe in his theories, but conceded his mistake when the work of Hubble and others showed it to be the case. There are, of course, variations on this line of understanding, even today, but in general, the model of an expanding universe that's accelerating has come to be widely accepted by contemporary science. Now, though, thanks to one controversial but potentially groundbreaking study, all of that might suddenly be turned on its head, and we might be reverting back to a static universe, bizarrely, more in line with early Einstein. On June 29, 2023, one Lucas Lumbrieser, a theoretical cosmologist, dark energy specialist, and professor at the University of Geneva, had his extremely fresh take published in the journal IOP Science. In the paper, titled Cosmology in Minkowski Space, Lumbrieser suggests that traditional ideas on universal expansion can in fact be reinterpreted, so that actually no expansion needs to take place at all, at least not in the typical sense. Lumbrieser purports that while the universe might seem like it's spreading out and out, it's not. Instead, it's static but fluctuating at the particle level, which is what really drives change. What was originally driving Lumbrieser was the infamous problem of the cosmological constant. Frustratingly enough, the cosmological constant is an unknown in science, but at the same time, it's required in order to make everything else make sense. It's the term then attributed to whatever it is that's driving universal expansion at the rate that we can observe. However, the numbers don't crunch the same at the macro and micro levels. Studies in particle physics propose that there's what's known as vacuum energy in the universe, responsible for driving it apart. But the cosmological constant as calculated through vacuum energy is up to 120 orders of magnitude higher than what more traditional observations suggest. Essentially, there's a huge disagreement as to the strength of the cosmological constant, and therein lies the problem. But back to Lumbrieser's paper, and the suggestion is that the problem is solved because it isn't actually there to begin with. Lumbrieser repitches what we already know, so that instead of expansion, we have an evolution of the mass of particles over a massive amount of time, which might create the illusion of expansion from our perspective observing on Earth. Lumbrieser writes that, quote, "This frame exhibits a variation of mass, length, and time scales across space-time," end quote. He goes on to explain that the phenomenon of redshift might be reinterpreted as a result. Science has always seen redshift as proof of an expanding universe, but actually, applying Lumbrieser's theory, it might really show changing mass throughout the universe, in which case the universe can be static and our observations still hold. There are implications in our search for dark energy too, because all of a sudden it might not even be there. Because if the universe isn't expanding as most mainstream science says it is, then dark energy isn't needed. It's unknown because it's wholly not real. Unsurprisingly, these have quickly become controversial ideas. For many, as neat as it seems to just flip the numbers and make them work in a different way, there are still way too many aspects of the universe that can't be proven or fail when forced through Lembrieser's model. However, for others, this could be the start of a revolution in our understanding. Again, no matter where it leads, and no matter how any one person feels about it, that's the beauty of science. It's never finished, it's never complete, and this latest shakeup is at the very least proof of that. Lucas Lembrieser is certainly no stranger to making bold predictions such as this latest one, however. In 2020, he led on research which concluded that we could be living inside what was then dubbed a Hubble bubble, a 250 million light-year-wide structure, inside of which the density of matter might be 50% lower than on the outside, i.e. than in the rest of the universe. There were then further suggestions that the wider universe might be populated with multiple Hubble bubbles. Lembrieser isn't alone in proposing such a setup, with many a multiverse argument also centering on bubbles in reality. Although again, his particular tweaks do appear to result in a unique understanding of how the universe might really work. At this stage, the more recent kickback to expansion hasn't been merged with the Hubble bubble model, but perhaps it's only a matter of time. But what's your verdict? Are you prepared to question everything we thought we knew about the universe? To rethink redshift not as evidence of expansion, but instead as hinting toward a cosmos that evolves and changes in an entirely different way? What is true is that, although the fundamentals of physics and astrophysics can feel as though they've been entrenched forever, against the full backdrop of human history, it's actually all quite recently acquired knowledge. Travel just 150 years back, and most of all of the major theories, models, and terms were either unknown or little understood. The Big Bang, universal expansion, dark energy, even the makeup and distribution of smaller galaxies. Science had yet to properly figure any of it out. And of course, we know that there have been some major revisions to our collective wisdom before, be that through Einstein, Charles Darwin, or more recently a figure like Peter Higgs. Change is always on the horizon. A complete U-turn is never quite out of the question. If the universe were found to be static after all, if it were proved that all of us had been looking at it all wrong for decades, then that would constitute a hugely major breakthrough. Right now, it's research only that kicks hard against the mainstream. A lot more work and study has to be carried out before it becomes accepted. But that's how scientists may have just discovered that cosmology is all wrong.